so much motherfucking design on right now.
Break it down, bring it back, make it clap. I got 3 old thoughts, new block, where that day. Pictures on my line, and you know
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. I am Habibah Azahra binti Muhammad Sofi from class LG2414B, and my group members are Nur Lailatu Izrin binti Ibrahim, Nur Anis Maisara binti Muhammad Hilmi, and Cikgu Nur Hanis Syafiqah binti Cikgu Samad. Today we will be presenting on the topic of the early stage diabetes data set using the Rapid Miner application. Rapid Miner is one of the most popular machine learning and data analytic environments in the market. Rapid Miner is an integrated enterprise artificial intelligence framework that offers AI solution to positively impact business. It is used as a data science software platform for data extraction, data mining, deep learning, machine learning, and predictive analytics. Rapid Miner also offers a free trial so that users can access its capabilities. The classifier can analyze patterns within the data to predict the likelihood of an individual developing diabetes at an early stage. The dataset may include variables such as blood glucose levels, body mass index or BMI, age, and other relevant health indicators. In this dataset, we will discuss the signs and symptoms of patients who are newly diagnosed with diabetes or are at risk of developing the disease. This information was collected through direct patient questionnaires conducted at the Silat Diabetes Hospital in Silat, Bangladesh, and all participants obtained medical clearance. Next, the features of the dataset is age, gender, polyuria, polydipsia, sudden weight loss, weakness, polyphagia, genital thrush, visual blurring, itching, irritability, delay healing, partial paralysis, muscle stiffness, alopecia, and obesity. Next, the objective for this title is to analyze the age distribution of individuals with diabetes and to analyze the gender distribution, identifying the highest incidence of diabetes within the population.
Now we are going to look at our first process, which is ETL process. Based on figure 1, it shows that are no missing value for every type of value in the data. By using Rapid Miner, it will help to improve the quality of the dataset through the early stage diabetes dataset, where this problem of data began. For this process, we use a few operators such as retrieve, filter example, map, replace missing value, set rule, and lastly select attribute. All these operators have their own function. Firstly, we need to import the data and drag the store operator into the data process plan to read Excel. If the data is ready, we can retrieve the data set. Secondly, we will drag the retrieve operator into the dataset process panel and run the data. At the same time, we need to drag the line until the end and click execution. If the dataset is successfully retrieved, a green correct indicator will appear. The next process will find the result for the filter example. Before getting the result, we need to drag the filter example operator and drag the line with retrieve until the end. After that, we will run the operator. If the dataset is success, the green correct indicator will appear and the result will be shown at the end. The next step is the map process. We need to drag the map operator into the dataset process panel. After that, we need to link with a filter example before running the data. At last, the result will appear after run the data. Another process is we need to drag the replace missing value into the dataset process like we can see at figure 8. After that, we need to link the line until the end and run the data. If the dataset is successful, the green correct indicator will appear and the result will be shown at the end. The next process is to drag the set role operator into the dataset process panel and need to link the operator with replace missing value operator until the end. After that, need to run the data and it will appear at the end if the data is correct. Lastly, drag the select attribute operator into the dataset process panel before we store the data. The operator needs to link with the set role operator until the end. After that, choose the attribute filter type to a subset and run the data. If the dataset is successful, the green correct indicator will appear and the result will be shown at the end.
We utilize two methods to decide which outcome is superior when modeling. The first one is split data, and for the second one is cross validation. Split data refer to an operator used to separate data into different subsets. This is crucial for evaluating the performance of our machine learning model and choosing the best outcome. This split data can be used for various purposes, like training and testing different models, comparing different training parameters, or performing cross-validation. For split data, first retrieve a clean data set of early stage diabetes by using the retrieve operator. Second, select the multiply operator and connect it with clean data early to deliver copy of it to the output port from the input port. Each connected port creates an independent copy. Third, the multiply operator is connect with the split data operator to be connected to 7 types of model like generalized linear model, decision tree, random forest, knife bias, neural net, gradient booster tree, and deep learning. The split data operator is set to 70-30 ratio. Fourth, the 7 model connect with the apply model and performance classification operator to get the result. After the data is separate, the algorithm is conducted to show the accuracy of each model, like gradient generalized linear model, decision tree, random forest, knife bias, neural net, gradient booster tree, and deep learning. The split data process repeat to get the net result. Cross validation is a technique used in machine learning to assess the performance of predictive model. It involves portioning the dataset into multiple subsets of faults. The model is trained on some of these faults and tested on the remaining fault. This process is repeat multiple times with different faults used for training and testing with each iteration. Cross-validation help to provide a more robust estimate of models' performance by reducing the impact of variability in the single-chain test split. For cross-validation process, drag clean dataset of early stage diabetes, then drag the cross-validation and connect with the data for the parameter, setting the number of faults to 10 for each 3 cross-validation process. Next, connect it with to get result. Example and mod. In cross-validation, for the training, track the model operator, for example, decision tree operator. After that, connect mod to mod as well as early training to the decision tree. For the testing, drag and link the apply model operator to performance operator classification. Then repeat the step to get the result of another model and change it to the specific model in the training session. For this cross-validation process, we combine all the operators shows like the picture and run the entire process at the same time. Cross-validation help to provide a more robust estimate of models performance by reducing the impact of variability in the single chain test split. For cross-validation process, drug clean data set of early stage diabetes, then track the cross-validation and connect with the data for the parameter, setting the number of 4 to 10 for each 3 cross-validation process. Next, connect it with to get result. Example and mod. In cross-validation, for the training, track the model operator, for example, decision tree operator. After that, connect mod to mod as well as early training to the decision tree. For the testing, drag and link the apply model operator to performance operator classification. Then repeat the step to get the result of another model and change it to the specific model in the training session. For this cross-validation process, we combine all the operators shows like the picture and run the entire process at the same time.
The graph analyzed the performance of several machine learning models on the early stage diabetes dataset. Firstly, Generalized Linear Model GLM. It achieved a score of 70.90 extended linear regression to handle various data distributions. Second, the decision tree scored 81.01, effectively capturing nonlinear relationship by recursively partitioning data based on the feature. Third, random forest. It attained a score of 70.43 by combining multiple decision trees to mitigate overfitting. Next, the knife Bayers. It scored 81.97, excelling its classification task by assuming feature independence. Then, neural networks. It achieved a score of 69.23, leveraging deep learning technique inspired by the brain structure. After that, the gradient boosted model, it outperformed others with a score of 82.21, iteratively improving on weakness to capture complex data relationships. Come up with deep learning, it scored 80.29, successful in handling large datasets in intricate patterns with neural networks. Last but not least, combined result produced a score of 75.96, likely employing ensemble methods or a fusion of models. The graph emphasized the effectiveness of decision trees, knife Bayers, gradient boosted models, and deep learning algorithms, highlighting their varied advantage depending on the task. It also underscores the benefit of combining diverse algorithms for better performance. Ultimately, practitioners should carefully consider each model's strengths and weaknesses when selecting the most suitable approach for their machine learning tasks. In conclusion, the early stage diabetes dataset serves as a valuable tool for researchers and educators in advancing our understanding of early diabetes prediction. The knowledge gained from this analysis contribute to the broader efforts aimed at improving healthcare outcomes through proactive identification and management of diabetes at its early stage. So, that's all from us. Thank you. So, that's all from us. Thank you.